All right, we are on day 3 of this unit, which is the second day of Trig Identities. And we're going to learn some more tools that we can use for Trig Identities. I didn't want to learn them all on the same day, it's just too much. So let's quickly review on how do we rationalize a denominator. So we've got in our denominator 4 minus 2 root 2. In order to rationalize that denominator, we're going to have to multiply, if it's a complex conjugate, by 4 plus 2 root 2. And the reason we're doing that is if we were multiplying x minus 3 times x plus 3, we know what happens because we get x squared, we get a plus 3x, and then a minus 3x, and then a minus 9. So the middle terms end up canceling, and we just get x squared minus 9. And when we multiply a radical times a radical, the radical should go away. So let's go ahead and do that. Now when you distribute this 2, it's got to be to the entire parentheses. So that, I'm going to start here. That will be 4 times 2 is 8, plus 2 times 2 is 4 root 2. Our denominator now is, and there's parentheses here, they don't ever put them, but they're around the numerator and the denominator, okay? When you multiply these two, just like up here, the middle terms are going to cancel. So what you'll end up having is 16 minus 2 times 2 is 4 times root 2 is just 2. So now our radical is not in our denominator, which is exactly what we wanted. So I'm going to work down, and we've got 8 plus 4 square root of 2 over, it looks like 16 minus 8, which is 8, right? Okay. So now all we have to do is simplify. When we simplify, we have to simplify, a different color here, 8 and the 4 and the 8 all together. Now, 8 does go into 8 evenly one time. However, we have to pull out a number that goes into 4 as well. And it looks like we're only going to be able to divide by 4, because 4 goes into 4 and 8 and 8. So 4 goes into 8 2 times, 4 goes into 4 1 time, so it's just root 2 over 4 goes into 8 2 times. Now you can rewrite that if you'd like, and you can just, I would just leave it. You could rewrite that as 2 over 2 plus root 2 over 2. And then you can go ahead and simplify that to make it a 1. But for now, we're leaving it there. So let's go on ahead and move on. These get a little bit more complicated. So when I look at this next one, and there are different ways to do these, okay? But the first thing that just came to my mind was, I've got a 1 minus cosine in my denominator. And these denominators have to end up being the same. So what I'd like to do is multiply this side, the right side. I'm going to work on the right side. And I am going to multiply by 1 plus the cosine of x. 1 plus the cosine of x. That way, I will end up with 1 minus cosine squared, which is equal to sine squared, which I'll show you in a minute. So again, there are parentheses here, okay? They don't ever put them, but they're there. Please remember that. When you get to calculus teachers, it's like a big pet peeve. There's a parentheses around the numerator and a parentheses around the denominator. It's very important. So when you multiply your sign, you have to distribute it. And again, we're working on the right side, so the equal sign is going to go on the left this time. So this is going to be sine of x. You know what? Maybe I'll leave it there, because sometimes when I distribute, then I make more work for myself. And in this case, I could. All right, so leaving it, not distributing. And I'm going to multiply these out. 1 minus cosine squared of x. Now, we know that sine squared plus cosine squared equals 1. So, whoops. if I go ahead, what's happening? Go away, go away. Try it again. If I subtract cosine squared, why? From both sides, what happens is we end up getting sine squared equals 1 minus cosine squared. I showed you that in the last video. So I can substitute in sine squared for 1 minus cosine squared. So I'm going to go ahead and do that because that's closer to the denominator that I need. So, and you know what? I should be putting my equal sign on the left because that's what we're working with, right? So I've got sine of x, 1 plus cosine of x, over, now this is sine squared of x. This is awesome because now one of those signs is going to cancel, right? So one of those signs is going to cancel, the squared is going to cancel, and I'm going to end up with 1 plus cosine of x over the sine of x, which is exactly what we need on the other side. So let me go ahead and write the other side now because we are done. Check. Now, had I gone ahead at the beginning and distributed that, I would have had to undistribute it. It would have been more work, so I'm glad I didn't. Let's go ahead and look at the U-try. Try the U-try. I'm going to show you the answers. Okay, so for the U-try, it's very, very similar. You multiply by the conjugate, and you end up with sine squared times 1 plus cosine of x in the numerator, and 1 minus cosine squared, which is equal to sine squared in the denominator. Okay, same thing we did last time. Both of those end up canceling. So now, when you distribute this 1 plus cosine of x is inside the parentheses, and the entire thing is being subtracted. So 1 minus 1, yes, bye-bye. But we have to minus cosine of x. That negative is like a negative 1 that you're multiplying. So don't forget this is a negative cosine. So strategy number 2. Remember when we had to add, simplify fractions that contained fractions? I think one of the easiest things that we're going to use right now is to get rid of the fractions. And the way we can do that is multiply through by a multiple of both of the denominators. In this case, 6. So if I multiply by 6 over 6, I can't just multiply by 6 because then I'd be changing the value of the expression. But if I go ahead and do that, and again, there's a parentheses around this entire thing, so I've got to distribute it. I'll end up with 6x over 2 plus 12 over 3, right? Over 6 over 1 minus 6x over 6. Now watch what happens. These are all going to simplify because we chose a number that 2 and 3 go into evenly, as well as 6 in this denominator. See, 2, 3, and 6 go into this number that we chose, 6. So we get 6x divided by 2 is 3x. 12 divided by 3 is 4. 6 over 1 is just 6. And then minus 6x over 6 is just x. Done. You're going to be using that a lot. All right, example 2. So there's a lot more going on the left side, and I'm not really sure where to start. So I'm just going to change the denominator into the reciprocals because that just seems like the easiest option for me right now. So I'm going to rewrite, and I don't know if this is going to work. You know, I'm just trying something, and that's what you have to do. And at first, this is a pain in the butt. You know, it kind of sucks because you're just like, I don't know what to do. Try something. Now, once I did that, I know that I've got to multiply the entire thing by, in order to add these two denominators right here, I've got to multiply both the numerator and the denominator by sine cosine, right, in order to have the denominators be the same. But I can't just do that in the denominator. I have to do it in the numerator as well. So I'm going to go ahead and multiply by sine of x cosine of x over sine of x cosine of x. Put my equal sign because I'm working on the left. Now what happens when I do that is my numerator becomes sine of x plus cosine of x times sine of x cosine of x. Those are different, right? One's got a plus in between, one's being multiplied. Over, now this is sine of x cosine of x over cosine of x plus sine of x cosine of x over sine of x. Okay, now watch what happens. These cosines will cancel, these sines will cancel. We end up getting rid of the denominator fractions, which is awesome. So let's go ahead and, I'm running out of room. I can't forget my equal sign. I'm running out of room, so I'm going to draw my arrow up here, and I'm going to continue up here. So I'm going to rewrite this. My numerator is the same. And so I end up with sine of x plus cosine of x. Well, sheesh. Sine of x plus cosine of x is exactly the same as this factor up here. So I can go ahead and cancel those factors. And what am I left with? I should put my equal sign. So I'm left with sine of x cosine of x equals sine of x cosine of x. So it did work out. Might want to look at that one again. So take a look at the U3D3. This is the last one. I chose to change tangent, the sine over cosine, and then multiply through both the numerator and the denominator by cosine to get rid of that cosine in the denominator because they end up canceling. That way, I end up with my son just brought my dog over to me. With this. The tricky part here is sine cosine plus sine of x can be, if you undistribute a sine of x, so it's the opposite of distributing. If you pull out, if you factor out, if you GCF out a sine of x, what you have left is cosine of x plus 1. Think about it. Sine of x times cosine of x plus sine of x times 1 gives you this numerator. Once you do that, you are able to cancel those, and you've got tangent of x over tangent of x. All right, I think I am done. Peace out.